Example 2, graph y equals sine of pi x. So, again, start with b equals something and c equals something. What does b equal?
1.
Very good. There's no number in front of that, so understood 1. C equals?
Pi.
Pi. Again, it's always sine of something x, and if it's just x, c equals 1. In this case, it's pi x, so c equals pi. B lets me find the amplitude. The amplitude is the absolute value of b, so the amplitude is 1. That tells me from 0, I'm going to go up one space on the y-axis, I'm going to go down one space on the y-axis. C is equal to pi, which means the period is going to equal 2 pi over c, which equals 2. So I want my 4 equally spaced dashes on my x-axis, like so. And I know my final value here is going to be 2. And if I do 2 over 4 equals a half, that's the amount I'm going to step per dash. Because again, 4 dashes, we take whatever the period is divided by 4 to find out how much I go up per dash. 0 plus 1 half is 1 half. 1 half plus 1 half is 2 halves, better known as 1. 2 halves plus 1 half is 3 halves. 3 halves plus 1 half is 2, or 4 halves, better known as 2. So just like that, again, we have the x dashes figured out. I've got the y dashes figured out. I'm ready to plot my points, and again, I have to determine, is it an otobo or an oboto? We can see b's original value is positive. For b positive, we go 0 top, 0 bottom, 0. So start at 0, always start at 0, top, 0, bottom, 0. Connect the dots with a smooth curve. Again, it looks pretty much the same as the other graph did. It's upside down from the other graph. Okay, so if I go to this one, type in y equals, and this is sine of pi x. I'm going to turn off this function, turn on that function. I'm going to set my window the same. I want to go from 0 to 2 at a 0.5 scale, from negative 1 to 1 at a 1 scale. It goes up, hits the top, goes back down to 0, hits the bottom, back to 0. So notice 0 top, 0 bottom, 0. Each dash, there's a dash top, dash 0, dash bottom, dash 0. So everything that's supposed to happen is happening. Again, what we have on our paper should match what we have on our calculator screen. If we set the window exactly the same, it should look like it's supposed to look.